We're now live. Excellent. Who wants to start us off? I see Thibaut's name at the top. Thibaut, would you like to start us off? Thibaut? Oh, you're muted.
Yes. Yes, sorry. I think I didn't hear you first time. It was like bad internet. Yeah. No. So just very quick on my side, I've continued enhancing the PGI PR, and thanks a lot, Joe and Lindsay, for the comment on that PR, and also on the smaller one I put in. So I think what I'm gonna prioritize, especially today and maybe a bit of tomorrow, is actually prioritize those smaller PR, and so that we can merge them in, and we can then merge them, and that will be that will be done for the bigger PGI PR. And yeah, so yeah, and on the PGI side, it's more like, as I say, it's like functionalities and tests are there. And I've started writing the documentation, but it's gonna take a little bit. And maybe Lindsay, later on, I will ask you also maybe what's the best way to acknowledge what we modify from the scikit-learn package.
Okay, yep.
Because like, there are like a number of functions from them that I take and rewrite. So do we put that in every description? I've started doing that, but I've also like put like headers inside the utils files to acknowledge it as a whole. So there might be some things to think about that. That's it for me.
Excellent. Thanks, Thibaut. So next to Thibaut, I see Xian. Would you be willing to go next?
Oh, me?
Yes.
Sure, yeah. So in our last meeting, Dr. Sun mentioned about sharing our synthetic model scenarios and also the data. So I'm working on that. Currently, I'm working on locally on my Jupyter notebook to have all the plots ready. And once it's finished, I will upload it to the GitHub.
Excellent. Look forward to seeing it. Jaja, I see you next on my screen.
Yeah, I don't have much to report. I had a meeting with Xiaolong last week talking about the cross-gradient inversion code. So we went over the code one more time, and what we're going to do next is Xiaolong, have you already done the PR or not yet?
PR, I already submitted the PR.
Okay. One thing that we talked about last week is to we realized that we need to do a few more tests, which we already did last year, but it was not organized, it was not documented, to make sure that our code is doing what it's supposed to do. It's calculating the cross gradient everywhere properly, and it can calculate the gradient Hessian properly. We did all the tests last year when we first started, but we didn't we didn't summarize that in writing. So we want to do that, start over to do redesign all the tests and do that. That will also be, as far as I understand, so that will also help you guys to make sure that the code is working properly before it's get merged, right? So that's what we're going to do next. Just basically design a few small synthetic tests. Yeah, to make sure that because it's a simple idea, but when it comes to computation, it's very complicated. So yeah, that's what we're going to do next.
Excellent. Thanks, Jaja. Xiaolong, would you like to go next? You can speak a bit more about the PR and such.
Yeah, as Dr. Sun just mentioned, recently I'm working on the test part for the PR I submitted last week. And another thing is I keep my eyes on the Thibaut's PR as well. Every time when he make a comment, I will take a close look at his code and the comments and trying to learn how to play this game well. This is what I'm doing recently.
Excellent. Yeah, and feel free to ping on your pull request with questions and things like that. So as you're thinking through the tests. If you have any questions, feel free to make a note and we can try and help you out there.
Okay, thank you.
Joe, would you like to go next?
Sure. Just really quickly, I'll go over things, a few things I'd like to talk about later after everyone gets through things. But I've been basically finalizing the reviews of a bunch of these PRs and getting them all into master still. I was helping, took time this weekend, was thinking about the MT simulation stuff that I was helping Lindsay and John with on the getting the fields working and getting it working simultaneously with the frequency domain EM base class. I think I hoped. I'll let them talk a little bit more about it. Maybe we can discuss it later. Yeah, finalizing this PR for the DCIP thing that Devin was working on. Kind of going through there and putting in my own edits, just kind of simplifying it up a little bit, reducing repeated code lines and things. And then later, I would like to talk about finalizing a few of these names for discretize that Lindsay had brought up. There was things that I had commented about that I wasn't quite sure of just yet. So I'd like to finalize those later after everyone gets through things, as well as what Doug had brought up on his pull request comments about the name of the fictitious source thing. So if we can go over that after everyone's gone through their things, that would be good.
Thanks, Joe. Doug, would you like to go next?
Yeah, I could. And it'll probably lead into what Devin has been doing. So Devin's been doing some, comparisons of SimPEG and UBC codes. And so I think, he'll talk about them, and they're actually looking really good. But I was going through his pull request, and just on the basis of that, I was trying to kind of really grab hold of the details of the mathematics that was going in and the details of the numerics that are being coded. I mean, the one thing about like the Python codes is that, they're kind of readable, but, there's things that come up and they're just sort of, a little bit mystifying, like, okay, where exactly is that coming from? And there's also a lot of subtleties, with respect to whether we got nodal based or whether we got self-centered based. And, these things they're easy at some level just to kind of, throw off and, say this. But, in the end of the day, kind of understanding those details are important. And then just now, we were talking about the code with Xiaolong and from Houston and Jia group, and he's talking about the cross gradients, and he said, well, in principle this is kind of straightforward, but in practice you kind of need to take care of a lot of details. And I think the same is true with the MT. So I think it probably doesn't matter much which code we're looking at especially for the simulation, because the inversions will be okay. Once you understand the forward modeling and the simulations, then now you've got things pretty much in hand. And I guess I was just wondering if there's some way that we can kind of tie in, what the underlying kind of mathematics actually is, and some details with respect to, the discretizations and where we're putting stuff and things like that. And we do have quite a bit. I mean, you had like pixels and their neighbors, and you've got a couple of things with respect to, EM and, HJ and EB fields, and, so we got a lot of stuff there. But I found myself yesterday, after kind of interacting with Devin and looking through, the code that he had, it's just like, okay, I kind of understand things, but I'm missing stuff. It'd be easy to slip up. And so I don't know, maybe that's worthwhile discussing? Maybe I'm the only person that has a problem, which I would not be
The same
surprised at. But anyway, maybe, I'm just wondering if that's worthwhile discussing. And I think if we're able to do something in that regard, it would really be a benefit. And then people would, have a really good kind of understanding of mathematically what's going on, numerically what's going on, and then see the Python code. And it's like, wow, I got it.
Yeah, there is a place for that. When we were first making the SimPEG website, the theory and the API and everything was all kind of smashed together. And right now it's all living in a place on the website under the heading packages. And yeah, when I was outlining sort of what I wanted to update for this SimPEG website, it seemed like a really good place to put a place where we actually go and do that. I don't think we need to necessarily derive a lot of things from scratch. In some ways, that's kind of what GeoSci is for. But we could start out with any one of our methods and say, okay, here's the formulation of Maxwell's equations for this particular problem. If we want to do, an EB formulation, and then we end up with, okay, this is how the discretization works, and this is where everything is living. I think that's extremely useful.
That actually sounds good. How advanced is it? I must admit, I haven't really looked at that, let's say for the DC. So for what's there for the DC, and then for the latest pull request that you've been working on in the comparison of the UBC codes and SimPEG codes, how much of that background information to understand the codes would actually be there at this point?
Well, I've been commenting stuff and trying to add, doc strings as I've been developing it, but I haven't put really that level of detail into the formulation. So I feel if you were reading through the code, the comments would be able to tell you what you're doing. But in terms of this nice packaged sort of thing that's kind of more focusing on, okay, how is the math working? I haven't developed that specifically, but it does basically exist on the website right now. So we just have this underdeveloped catch-all area where we're talking about the packages that SimPEG has. And I mean, I could go and try and clean that up and turn it into that theory section if we wanted to.
So if you don't mind, I'm going to hit pause on this conversation and we'll keep going around, and then let's circle back because I think that there's a few things to unpack here. So if folks do have ideas, or if you have a thought right now that you want to make sure you keep in mind, just add it to the notes under Doug's name, which is on the second page in the quick reports, and then we'll circle back and make sure that your notes and thoughts are captured. So yeah, is that all right?
No, that sounds great.
Okay. Doug, was there anything else you wanted to sort of add to that point while it's top of mind for everyone?
Oh, I think that's fine.
Okay. Do you have any other things?
Nope.
Okay.
I'll be fine for now.
Excellent. Sounds good. Devin.
Sure. So yeah, the pull request for potential fields is merged. So we have a much more stable formulation for the sensitivities. So that's great. And then it also led to me creating an IO utilities section under utilities. So it would be nice to be able to just easily import and export all UBC formatted data files for all of our codes. And I'm basically building that library right now. So we have all the ones for our potential fields codes. And then this latest pull request with the DCIP is going to have the DCIP ones. So it's going to be really easy to just import and export UBC formatted data. And then, yeah, I mean, I did these code comparisons, the UBC versus the SimPEG, a whole bunch of examples, and I think we get really quite good agreement. So I'm pretty happy with what SimPEG is doing, and I think it's quite accurate and it's fast, and I'm really happy with that. So I have those yeah.
You had a bit of problems, right, when you're comparing with the block example. Like, did you kind of figure out what the problem was, so it's kind of resolved?
Yeah, I would say so. I mean, I just needed to go and really look where things were being where things were being defined on the mesh, and then the big thing was that method of fictitious sources. So right now, the original way that we were creating the sources, it would kind of interpolate to nodes or to cell centers or find the nearest one. That wasn't particularly accurate for things that are sensitive to the very near surface, and that motivated this fictitious sources, and that works really quite well.
Okay, cool.
So we don't have to get into crazy details of it, but I added a new way of computing the sources, and I have ways of, we've compared all of the things that SimPEG and that UBC code is doing, and we have those validations in notebooks, and there's markdown, and it explains everything. So after this EIP pull request goes through, one of the things we might think about is where those validations are going to live so that everyone else has access to them.
Nice. And so, it is like sort of complete, like you can use both for like a CC problem or CC simulation and nodal simulation?
Well, I'm doing it with the octree mesh. So as of right now, the boundary conditions on the tree mesh wouldn't allow me to do a cell-centered formulation without creating kind of air cells. So if you want to do something where the topography is flat and you have all your electrodes on the surface, you need to use the nodal formulation if you're doing a tree mesh. But I mean, we have a formulation that works very well, and that would be the one that I would suggest using anyway. So,
okay.
Yeah. So it sounds like right now I've been working on the doc strings for the discretize website, and maybe I could think about doing this background theory type stuff. But yeah, I have my hands in lots of things. That's about it.
Thanks, Deb.
There might be a few things that we want to discuss later, maybe not now with respect to what you're calling fictitious sources, but I'm just wondering if you ever did a test. So all of your tests have been like with something buried in a half space. Did you ever do a test where you put two blocks in quarter spaces?
Not yet.
Because there you have it. Now you're going to use something where you actually don't know what the background is.
Yeah.
And would you expect that's going to cause a problem, or have you tested it?
I haven't tested it yet, but I would imagine that the error might be a bit larger, and then you may want to choose to define your right-hand side in a different way. I mean, it's true. Yeah, if you're using this method of fictitious sources, you have something within a homogeneous media that's going to be making your life pretty easy, and you're definitely going to get the background response because you're using an analytic solution for it. But yeah, I could imagine putting some kind of dike or blocks like that, maybe give different results, but I haven't gotten around to it.
All right. Thanks, Devin. I had one question for you just on the IO utils. If you started an issue that maybe sketches that out before starting a pull request, just so that we can maybe have a bit of a conversation around the structure and if there's things that we want to sort of think through before implementing.
Well, it's part of the current set of pull requests. They're utilities that I needed to develop in order to do these validations, to be able to do the work that I was doing.
Okay.
So they're kind of being developed as I'm working on other stuff. But we've had several meetings over the past couple of years about doing something similar, and it never moved forward. And it's something that we need. So I guess I'm maybe more likely to try and just give it to the people.
Okay, Joe, do you have comments or thoughts on, because so one thing in general I would say is, you know, if we are going to be trying to sort of, it's helpful to sketch out an issue first, to just kind of communicate that you're going to be working on something, and then also to give folks a chance to chime in. Joe, yeah, I don't know if you have other.
Yeah, I mean, also like I don't mind them like having a bunch of IO utils, and like people can just go, like I kind of like the idea of having that as a module, because a separate like, you know, folder module, because then we could go in and add, makes it a little bit a place, it makes it as a place that can be like, oh hey, if you want to add a read in for this file, put it in this module instead of randomly somewhere else. So I kind of like that idea. But in general, yeah, I would have preferred that these, like there's two parts of this PR that I think should have been separated in the first, but.
Yeah, no, that's true. That's a good point.
All right, thanks both. Dieter.
Yes, last week was mainly this automatic reading that is now in EMG3D, which is now within the consortium. It's now easier for the others to, with the command line interface, throw their model they have. They have it usually from gravity, so it has very different dimensions than my CSCM mesh, and it does all the meshing as sensible as possible and gives it back on the same scale. So it's probably going to have to improve over the months and years, but it's an initial step is there for that. And I hope it will also make it easier for new users that are not that familiar how far away you have to put the boundary, how small you have to make the cells at the source, and all these things to model something that is correct. I usually went on the very conservative side, so your mesh is probably has many more cells than it needs to have, but it's maybe the better approach. So it might be slower for new users, but at least the result is correct. It's a kind of a trade-off, but yeah. So I will see how that goes. And as I wrote, I once, if the meeting's not so busy in the future, once I can give a quick rundown of this if it's of interest, together with the command line interface. Yeah.
That would be great.
And that's it, I think.
All right, thanks, Dieter. John.
Yeah, actually, yeah, I've been helping Joe and Lindsay there with the frequency domain dependency for the natural source. I started the PR for that part 1 there. And yeah, it's going really well, pretty much by having the source define that it has the multiple polarizations, or does it just have number of sources, or sorry, I guess it just has another parameter that just tells it if there's multiple polarizations. And yeah, I took Joe pushed in last night, and I put it all into the other receivers. Tested that out. So the tipper and the complex resistivity, or I guess the resistivity in phase, now all work. And pretty much the simulation class is super lightweight now. Yeah, I guess I'll start cleaning up here going the next couple of days. And yeah, maybe I'll point out some things that we can improve, or if there's anything else that we can look at. But yeah, that PR should be ready pretty quick here. Thanks a lot, Joe and Lindsay. That was actually a really good sprint there.
Is it?
I did have a quick question about that. Like I said, I never got around to testing if I implemented it correctly, like if I tracked everything correctly, but I thought I did.
Yeah, no, it's all the forward modeling stuff is we just have, like you said, just have to modify the mi sigma derivatives just to catch the right sizes. And yep. Yeah, the inversion should be working. That's just as far as I got last night, is to, yeah, just having to modify that, and I got a little tired. So okay. Yeah, no, that's all good. And yeah, I've just been dabbling still in the tiling side for the DC. Yeah, I found out exactly where it's breaking, and I'm just gonna see what I can do. But that's about it.
Excellent. And with that, how far out do you think the tiling is for MT?
It really shouldn't be that long. Like as soon as we get it for the DC, I really just have to, you just have to make the tool that divides it up, the simulations into the frequencies. So I don't know. I'd like to say it'd be like a week's worth of work, maybe. Nothing too much. Yeah.
That's exciting. Excellent. Sagi.
I had one more question for them. I'm assuming you guys are doing this all for tensor mesh for now. Is it in your immediate plans to get it working for tree?
Joe might have to feel that one.
I mean, we're trying to do it in such a way that it's ambivalent to it. There's a small, I know what needs to happen to make it work for the tree mesh, and I've talked to Lindsay about it a little bit, brought it up a little bit. It's like a little bit of a line of a code that should be changed and made more general.
Okay, yeah.
Excellent. Thanks, John. Sagi.
I have nothing really particular relevance here. I kind of maybe I was a little bit frustrated getting like a KIP comments from Jenny. I think she's an Italian girl. Like she's trying to use both SimPEG and SimPEG EM1D, and the structure is very different. She's like that. She's using the older version, so in the problem class. Yeah, so I'm just keep getting kind of questions from her. It's not matching. It doesn't work, and I'm trying to kind of explain bits and pieces. Yes, I like it's absolutely because of the lack of good documentation, I guess, and also it's not just the documentation, but I wasn't sure what's the best way. She's like it feels like there's like quite a bit of knowledge gap between users and developers, and I don't know. Yeah, I wasn't like I was just kept frustrated because like I just keep answering her questions and explain like as much as I can, and then what keeps coming back, it doesn't work, and it's not matching. Yeah, I wasn't just sure how like what is the best approach to really make it useful for people who do not necessarily have a good understanding behind about the physics and the problem and data. Anyway, that's where I felt, and a little bit upside, I was working with them a little bit about quest data. So there was a big IP effect in airborne data. And this is something that I haven't done. Like I've worked on small data set, but this is actually a pretty big data set and don't really worked on. There was a talk in the SEG, actually in the machine learning session, who talked about the negative. So I was excited. Oh, okay, we can actually revisit that. So we're we're in the process of revisiting and see what correlation we can find from airborne IP and the geochemical data sets.
Oh, cool.
So anyway, that's where am I.
Very cool. Well, we can maybe circle back. I think, Sagi, your comment about sort of users and documentation, I think ties quite nicely into Doug's question about where we should be documenting things that are more on sort of that intersection of, you know, theory and practice. So I think that all feeds in quite nicely. Yeah, like just one comment was my feeling, if you got kind of tight connection, like so we can set up a call and just like have a casual talk, then it's sort of fine. But like Jenny is an example. Okay, we're not going to have a very casual conversation with her, but like basically we're interacting with codes and some mails or whatever, like in a documented media. Yeah, I think it would need some sort of effective mechanism. Even just with that, we can interact. That could be quite good, but I'm just not sure how we could do that. Yeah, that's a really good point. I'll give a couple updates and then we can maybe circle back to some of these discussion points. So a piece of good news is we did get the IRIS funding for developing a processing code for MT. So really excited about that. We'll have some more details. We should be getting in touch with the IRIS folks, hopefully either later this week or early next, to kind of get a sense of getting things up and running. But they were quite positive on sort of our community approach. And so I'm very excited about that.
What does that include? Sorry.
So
this funding.
So the goal is to actually go in and basically develop an open source version of Gary Egbert's MT processing code. Well, there's two aspects. There's that, and then there's also some work on MTH5, which is meant to be an archival and storage format for MT for processed data. So there's, yeah, both pieces of that is sort of the MTH5 format, having that interoperate nicely with tools like Dask, Xarray, so we can, access that in parallel. And then the processing, development of a processing library is the bigger portion of the project.
Does it include a PhD position, a postdoc position, or any funding, or?
So it does include funding for development. It's not substantial enough to support a PhD or a master's student. I mean, it could do a small slice of sort of some internship work, but yeah, it'll be mostly for development. So this is with, we put it in with Carl Kapler. And so he'll be doing a lot of the development work, and he's got a lot of MT experience, and he's currently in California. So a cool chance to onboard somebody new to the community too. Cool. Other items, yeah, I guess Joe mentioned this already. I added some notes on the discretized PR with respect to naming, so we can circle back to that. And then the other big item that I'd appreciate folks taking a chance to read through is I started to sketch out a document just to kind of start a conversation about what we want to have in place for SimPEG governance. This is the goal. My goal here is to have this be a very conversational document. So please feel free to add your own notes, thoughts, comments. It's meant to be a starting place for a discussion. And so we can sort of have that document, get your thoughts down, and maybe either next week or in 2 weeks' time, we can maybe have a bit more of a focused meeting, just kind of thinking through some of the governance items, what kind of questions we need to be able to answer, and what we want to have in place. And feel free to ping me if there's anything you want to chat about one-on-one with this or anything like that. I'm very happy to. I think this is an important conversation for us to have. And yeah, getting your thoughts down would be much appreciated. So with that, let's maybe circle back to some discussion items. So there's 3 things. As Joe brought up 2 with respect to mostly naming with pull requests. And then we have the discussion with respect to sort of the simulation, forward modeling, capturing this theory process sort of interaction. Does anyone have opinions on which ones we start with? No? Okay, let's start with Joe's comments.
Just a few things. So generally, like I brought up in here, is that as long as like I don't have anything against changing anything that's not a keyword argument, it doesn't really matter. It's, the user will still call it with the same thing. It doesn't matter. So we can change them whether or not, and that's fine. The other thing is I'd like to talk a little bit more about this VNE property. On the pull request, Lindsay had mentioned naming it as shape. I've kind of pushed back on naming it as shape because it's not actually a shape. It's like a list. It's like a list of the number of edges in each direction, like along each component. So like if it's going to be named anything, I think it should be closer to that. And even if it's like explicit, what did I put on there? On the notes there. Like n edges per direction or per dimension or something like that. That's kind of what that property actually is. And it's not, like I said, it's not one of the shapes, it's just the number of edges per direction. If that makes sense, I think that'll probably be happy. I think that was the only kind of other property that the only other thing that was outstanding on that. Everything else is all internal and it doesn't really quite matter to the external world.
The other one that I had in mind was the grid.
Yeah.
Do we want to call things, so right now we've got like grid CC, grid N. And so when I was looking at the code, I found actually sort of the grid cell centers well, I don't know if we want the grid. Do we just want to call it cell centers? Faces X, faces Y, faces Z.
Yeah.
Is my question.
Right. So the two arguments, like for leaving it as a grid, is that, okay, well, we kind of have this bias in our head that, yeah, grid does imply some sort of structure to it, but then there's also, you know, unstructured grids, unstructured, these other things. So it's like, okay, that's kind of an argument against that. And then having them all as grids allows you to do tab completion to see what lists of locations there are on when you're writing the code. That's kind of the only arguments for keeping it. It's like the only argument for keeping it as grid is to make tab completion easier. Talk, I know you had some thoughts on this earlier, but
I think I'm sort of on the conservative side, but I think I'm pretty much open to any choice. Yeah. I think I don't have like a real comments here.
Yeah, I think like cell centers looks cleaner because it's just like, oh, this is the cell centers. These are the nodes. These are the edges.
Yeah, I think as long as like there's a little bit of buffering time that I could like, oh, okay, this was degree CC. So like you're gonna kind of leave like this. I'm not sure what it's called, but I can still use degree CC, right? Then at a certain point we'll deprecate that.
Yeah.
As long as we do that, I think I'm pretty open.
I think the only kind of issue that might cause is that one of the old so I think one of the old, like if you wanted the edge lengths, previously you would be like, oh, mesh.edges or something to get the edge lengths, which didn't really quite make sense. So we might have a little bit of issue with that, but I don't know. I have to look at, because we have like edges X and edges Y and edges Z.
Yeah. I think there are probably very few people who use that, I guess.
Yeah.
Really like writing the core part of the simulation would use it. But other than that, I don't really see like a many kind of use cases. So that part, I think you should be like a little bit feel better about changing it. I think probably very few.
My thing was that I don't mind changing that. Like edges should just be like edge lengths, face areas. You know, that's what they are going to be, and that's what it says in there. But I'm just saying it'll cause a little bit of a clash for renaming something as, you know, edges that now does something completely different than what it used to. It's just a little bit of a name clashing there.
Yeah, I think though, to Sagi's point, I don't think many folks would be touching edges unless you were actually writing a simulation code. Like grid CC, that's one that I think everyone's touched is because you're building a model, but yeah, I wouldn't be too overly concerned. What actually prompted me with sort of thinking, revisiting sort of getting rid of grid is actually looking at a lot of the code. Like when we do it internally, you end up just saying nodes equals like mesh dot grid nodes. And so like that naming difference, that's sort of what prompted me to really think that maybe we should just get rid of the grid and just call it cell centers.
I'm in favor of that. I think it looks cleaner. I like it better, but it's in a point where I can switch it very quickly.
All right.
So if everyone's on board with that, I think I'll do it. No objections. Okay.
I think it would be good just because everything got very long anyway because we're much more verbose.
Mm-hmm.
So this would be at least some 5 letters or something. Savement on many things. But yeah.
Excellent. Okay. Well, if anyone doesn't want to disagree on camera, you have time to chime in on the GitHub pull request, but otherwise, we'll take the nods as we have consensus. Cool. Joe and Doug, this one comes to Doug's point about the names for fictitious source. Doug, would you like to maybe give just like a quick summary of what you had mentioned there and we can open that up?
I guess it starts with after having gone through the code that I didn't really understand what was going on. And I didn't really know where these fictitious sources are coming from and how they're being used. So I'll come back to that. But just the name itself for DC resistivity, a fictitious source is often historically like an image source or something like that. You put a current in the ground and then you've got an image above. And so then that naming is, it will be confusing to people. There's other names that we could adopt, but it actually depends upon how this source is being used. And many years ago, back in the early 2000s, we got pretty excited about using what we call corrective sources. So if you're going from one grid to another, if you want to work with an inversion program that was sort of a subset of a big system, especially when the loop was outside, then we actually made what was called a corrective source that could be added to the equations, and really it kind of accounted for the fact that you're working in a slightly different domain. So the whole business of, there's a naming thing with fictitious sources, but there's also just an implementation part that really worries me with respect to when you've got situations with topography, because I don't see how you can just shove in an analytic source for a half space and have it applicable in all kinds of situations. And I brought up one where this is sort of like a sanity check. Is this going to work in a case where you've got quarter spaces? But the other one that I think could be useful, not only for the DC resistivity, but might actually be sort of a generic thing we'd use in all of our EM. And that is the case where we've got topography and just represented by, I don't know, sort of like a trapezoid. So we've got something, you can imagine a flat surface, and then you've got a mountain that's just made out of two sloping lines, and it's got a variable flat surface. And if we had something like that, then we could just kind of use that as a bit of a check to see when things start to break down, and then to decide whether we want to have these fictitious sources still be what Devin has programmed in, or maybe we want to think about something else. So those are sort of my kind of concerns and thoughts. But I think it's too early to, first of all, ratify the technique of just using those analytic sources, and secondly, then what we actually call them.
I think I kind of like the name corrective source better, and that's essentially what this formulation is doing. But it's just like corrective source with a half space, like with a half space solution. So I would assume that would only be valid if the model is close to a half space, right? Like even if the source is buried, it'll still work because we have the solution in a half space for it. I would expect that
there's flat topography or approximately flat topography.
Yeah.
But I guess I'm not proposing we replace the pre-existing simulation. It's just another option for how you would like to discretize your right-hand side. I feel it should be a choice.
I think what Roman did was more like a sophisticated, because that's how the UBC code works, the octree code, not the tensor code. But actually, he used this imaging principle to derive like he take account those topography effects. So I think that's how that the UBC DC octree code works.
Yeah,
so
that's what I did. I talked to Roman, and then I implemented the same thing that the DCIP octree does.
Okay, so then I think
it's interesting.
Parallel, but it's still worthwhile to test when we got topography.
Yeah, I don't think it's going to be robust to extreme topography, but for something like moderate or modest, I think it does account for it. It's supposed to reasonably well. I agree that you can break it. I think that you could break it if you wanted to.
To Doug's other point, though, this was kind of one of the reasons I brought up before about having a more general form of this kind of right-hand side solution, to where, okay, yeah, I like the name corrective source better because that's actually what this is doing. If you look at some of the papers that Doug linked there, this is the same formulation as that kind of corrective source. So what that, I mean, I like the idea of just kind of being able to have the source and being able to give it a, just ask for a solution back from it for a primary field. It doesn't matter how it does it, just be able to give it a function that, given a source location, it'll give you back an analytic solution or give you back a solution. It doesn't have to be analytic. Kind of makes you think that we could mix maybe integral techniques to account for topography in some situations, because that's a little bit easier to account for those and that kind of thing in an analytic sense. Or we could, as the other said, mix in fine-grained octree solutions to this in those simulations. That's kind of, I would like to move that forward with that kind of thing as more general case that we could use and apply to all these systems.
Yeah, and I think to Doug's point, well, correct me if I'm misinterpreting, but I think there's an important question here too of when do we include something in SimPEG when it is something like this that is not necessarily we're not at the stage where a user can pick this up and sort of use it responsibly necessarily, right? As we haven't actually vetted if it's working with topography, what sorts of edge cases we need to be careful with. So I think it's an important question as to when do we actually want to include something in SimPEG, and if we do include this, should we be throwing warnings right now saying that this is experimental, or should we hold off until we sort of think through a bit of a more general implementation that could account for topography, look at a fine octree mesh. I think that's, Doug, is that a fair statement of?
Absolutely. Yeah, I think we want to be really certain in our own minds what we're actually implementing and testing it, and getting some notes on it so that people can understand it, and then release it. Otherwise, people can potentially misuse it or get confused, and that's ultimately going to be a bigger sink for our time.
Yeah,
I like the idea of the warnings, because I guess I don't like the situation where we're developing something and it's getting close to the finish line, and then because it's not perfect, we don't want to release it. And there's all these tools and all these things that people could be using, but then we hold off because we're being very careful. And I like the idea of putting some kind of warning that says, okay, you have extreme topography, this particular formulation might have large associated errors. You're probably not implementing this properly, because it allows us to really regularly release improved tools to the community. But we do want to make sure that whatever it is we release is working properly and that people are implementing it properly. It's a very good point.
I would say we could just implement a warning on the class as a whole, and just being hey, this may change in the future. It's currently experimental. Yeah. It has not been tested, under topography effects or variable topography, just things like that. I would be okay with putting that kind of warning on it, just so it's transparent and saying that, hey, this will likely change in the future. So that is something that, other code bases do that kind of thing too, where they put in warnings, future warnings that, oh, this code is going to change, don't use it like this.
So that's one potential solution, but I think this is more than just this code might change. It's that we haven't verified where this code works. And I think that those are two distinct things, and it's important to sort of if we include this in the SimPEG package, I mean, there is sort of a, like, at this point, a responsibility that it's working. And so it's something to sort of think through. Yeah.
I can do that, I think, sometime in the next few days. We have an analytic solution for a hemispherical bite getting taken out of the surface, I believe. Although I don't think you can put the sources and receivers in that bite, but I'll look around. I'll try and find an analytic solution where there is some kind of strange large topography, and I'll throw the whole suite of formulations, UBC, SimPEG, the different sources, and we'll just see what comes out of it, and then we'll answer our questions. So I'll get on that. I'll try and break it with topography and see which one is going to be the most robust.
And that particular formulation could either be a hemispherical dimple or a hemispherical lump. Is that correct?
Yeah, the only thing I'm not sure of is if I can put the electrodes inside it, and I don't think I can. I think you put them on either side of the depression or the lump.
I was going to ask what the difference between the lump and the dimple was.
Excellent. Cool. Okay, we'll look forward to seeing that. And if folks have other thoughts on this, feel free to chime in on that pull request, and we can keep iterating there.
I think at this point, then I'll probably do a release of SimPEG for now without that in it. I think the PR should be coming a lot quicker now that we have the little bug worked out that was causing me so many issues. So PR should be coming in quicker.
That sounds good. Okay, and then coming back, I know we've just got 5 minutes, but that's still a few minutes to start thinking through this discussion item that Doug brought up about where do we perhaps want to put resources on computation, and I think this also speaks to Sagi's point of, like, what sorts of tutorials do we perhaps need to get folks up and running so that we can point people to resources rather than one person having to answer emails. Doug, do you want to, is there other things you want to add to my intro there, or?
No, I think that's it. I mean, just some way that, somebody who's even knowledgeable with respect to, electromagnetics, could kind of wend his way through and see exactly, which formulation is being used and how things are being, evaluated, and then make a complete correspondence with the, with the code, so that, if there's a particular formula that's used that is readable in Python, or there's minus signs or something that's coming in because of this, that you kind of understand where that's coming from.
Yeah. So I think there's, because I think there's actually 2 sort of levels of resources potentially here. And Dieter, I'll let you chime in with your comment too, and Devin here. But I think, so what I potentially see is, yes, there's the theory section or the packages section that Devin pointed out in the documentation. But in some senses, I don't know how in depth we want to go into theory in the documentation, or if we want to start to think about a collection of more lightweight pages, or like a blog or a book kind of thing that includes tutorial information and sort of descriptions in a bit more depth with respect to some of these concepts. Dieter, I'll let you speak to your comment here too.
It wasn't really just something to keep in mind, because Doug said, well, Python, it's nice, you can just read it, but it can be very hard to follow it. And I think it's not actually a Python thing, but it's a thing from the object programming paradigm, that everything is inherited and has a state, and particularly if you're not often using the code, this can make it very difficult to follow it, which, I don't think it's a Python kind characteristic. It's a paradigm characteristic that SimPEG follows and makes it very powerful, because it makes it very flexible, but it can make it very hard to get into it, which, yeah. Just something to keep in mind if this could be eased, because we all have looked at the code very much, but someone who comes new in is like, you look at the simulation and it inherits a base simulation and probably a base EM simulation, and it inherits a base simulation, and then it's very difficult to see how and where is all that stuff getting set. And then it inherits on top of that discretize, which is an entirely different package, but does do all the maths on edges or on faces. So this is one of the struggles to read into what does SimPEG actually do, I think. Which is not a solution, it's just a comment, unfortunately.
Dieter, within your consortium, like what sort of kind of communication problems have you had? Because you're working with other, with other groups, and you're sort of, they're using part of your codes and packages, and you're using part of them. And at what level have the communications been challenging?
Somewhat different, because we just have to agree on the interface. And so like the main joint inversion framework accesses all these forward modeling codes and has little wrappers for the data format. And in the end, you just have to agree how do you pass along data, but you don't talk directly. It's all reading in a file, and then you have to agree, it comes X first or Y first, or how is it sorted, and is it positive set up or positive set down? And once you agree on all that, each package can do whatever it wants. So there it's really just an interfacing issue.
Okay.
Dev, you had a
which makes it very, I mean, it's not open source, that framework, right? My code is, but all the rest not. And it makes it completely useless for anyone else. So we talk here at SimPEG about a completely different beast, because it's used by many. Also, people use it the first time, and in this framework of the consortium, all are the experts of their code. So it's a different kind of communication.
Yeah, I guess what I was going to say is I dropped a link in the chat to a Google Doc that I put together some months ago about the general structure of the SimPEG website. And I think people have already gone through and given passes of it and commented, but it sounds like this is sort of answering a lot of questions about where to put stuff. And we all seemed like we were pretty okay with the structure. Some of the stuff like analytics, we decided to put in the GeoAna, but there is a place for theory, and it does separate this theory section, which we all seem to kind of want that's separate from what you would be putting in the doc strings of the API. And if it's a priority, then I'm totally willing to go for it. I think I was maybe diverted to spend some time on the Discretize website, but if this is what people really need right now, I'm willing to go work on it.
So when you say website, do you mean the documentation? Because I think like the SimPEG website is SimPEG.xyz.
Oh, sorry, I mean docs.simpeg. So yeah, the SimPEG package.
Like the documentation, okay.
Yeah,
Just
yeah.
to be clear, like, yeah.
Yeah, sorry about that. But yeah, I could spend time and energy on that if it's a high priority item, no problem.
So, oh, go ahead.
No, I was curious about where to put, for instance, what Doug asked for was very gory details.
Yeah.
How code is really implemented, what is the background theory. So you need quite a bit of space to put that in. And I was curious about whether we want to put that into SimPEG documentation, or we have a separate like a kind of UBC style, manual style document, like you dump everything into the documentation. Yeah, I wasn't sure, but I was curious where to, let's say we're putting the gory details of all the pieces of the code, then where are we putting in?
I don't think it has to be like crazy gory details, but it would be nice to just start off with the, the PDE or whatever we're starting, whatever Maxwell's equations, how we manipulated it for a particular problem, and then just show a reasonable amount of steps to get to the final discretized system, and just say, what kind of a boundary condition was implemented, and then what does that sort of mean for how you're going to set up your particular simulation. Like just making that connection, I think, is maybe the biggest thing we want to put in there. I don't know if we have to go too far down the rabbit hole.
I would kind of agree with that. I think that, if we just have enough, at least for me, on this particular example, just enough so that we could actually start at square one and either have references or little cubical diagrams of fields and fluxes and where things are and what the equations are, and then how the steps are going through. A very kind of summary with respect to what the process is and what the equations are.
Yeah, it seems
I think
like
that would go a long ways.
And it's like almost like a slightly more detailed version of what the UBC manual theories are. And I mean, I refer to them regularly. I think I've pointed John there for MT stuff. I've regularly pointed people at theory sections for UBC manuals, because then you are like, you understand what the formulation is and how they're solving it. So I think that's like a good starting template. We might cater it a bit more to the SimPEG audience, but there is something that exists that is being used right now, and somewhat successfully.
Yeah, I think that's got sort of a little bit of the right feel, but I think we'd need to go somewhat deeper to be a bit more technical. I mean, the current UBC documentation, I mean, it's kind of got the equations there, but really there's a big step between that and the actual implementations that would be nice to uncover.
Yeah, I just want to follow up on what Devin and Doc mentioned. I think, Doc is exactly right. So we have equations, but there's a big gap between equations and implementation. So maybe I'm out of my mind. Maybe the tools are not existent yet. But what I'm envisioning ideally is that we'll have like a web page. It's super long, and on the very left-hand side you have the 4 equations, and then you go to the the next level on right next to the equations, and then you get into the discretizations, and then you get into the next level to the right, and then you got the equations that you actually use to code. And then the last level will be the codes. And when the user click one equation, and all the codes that are used to implement this particular equation will be highlighted. And so I don't know if that the tools exist or not, but that will be really, really helpful. You will go from Maxwell equation, 4 equations, all the way to the exact details of how things are coded, right? And I think we have the pieces probably out there, most of the pieces. It's just a way of how to integrate them together into a user-friendly, I don't know, browser or web page, something like that. Something is missing there. To understand the code there, you have to be really familiar with the Maxwell, the EM theory, and also you need to be really good at the numerical solutions, how things are discretized, finite volume, finite element. Then you need to be also familiar with Python coding, which is quite challenging for non-code developers like me. When I read the code, I know Python is pretty proud of its readability, but to me, it's not that readable sometimes.
Yeah, I think that sets the bar. I think we need to have some sort of tangible plan. So it'll be great, Jaja, if you could do that. I think the current sort of status that we face, it's a bit far to do that. So I think we could probably make some sort of incremental.
See, I can do the first 3 steps from max. For example, take DC, for example. I taught this in fall semester 2018, 19 for my graduate students. I can go from Maxwell equation to discretization to all the equations. But the last step I cannot do because I did not develop the DC code in SimPEG. That would require someone else to link my equations to your code, right? When someone clicks that probably will, like, let's say 100 equations. Anyone click one equation, and then that equation will be linked to all the codes in SimPEG that is used to implement the code. Last step I definitely cannot do because I didn't do the code. So it would be someone like Devin who are familiar with all, from theory to discretization to all equation to codes to do that.
So I like that vision, Jaja. I'm kind of with Soggy a little bit on trying to maybe do this incrementally.
Oh yeah, of course, yeah.
Yeah, and so kind of thinking about, you know, some kind of a document, whether, I'm not sure what the best form of that document is.
Yeah, right.
That's just kind of got like the bare bones stuff of like, oh, okay, this is how we get from A to Z.
Yeah.
And then that would form then the basis for, now we've got all of these pieces. So here's, now we could enact your vision of you know, just clicking on something and seeing where it goes. So I think that's a great vision, but yeah, we might want to have something that's kind of intermediate at this point.
Oh yeah, of course.
From what I'd imagine then is I'd like to at least see, like, on these simulations and stuff, like almost essentially the bare minimum being like, you know, this is the equation that we're solving. We're discretizing it on, like, so the node, we're discretizing it for the potential nodes. We're going to use these discrete matrices to solve it. Like, I feel like that would kind of be like the simplest way. And then, okay, if you'd like to see how the PDE was derived, go to this area. So it kind of like gets it all kind of like an encompassing thing. Because if you look at like the EM, like that frequency domain EM stuff, like there's a lot of details in all of them until it takes a while to get to the actual thing that is being solved. So I kind of like, I would say as an intermediate, just, okay, this is what's being solved. This is how we're solving it. If you'd like to see how we came up with the original equation, go to here. It's kind of an intermediate thing.
Is there a good way to sort of reference where the API, like say, here's like, we were solving AX equal to B, and here's A, and then that, like, this is where the code is to generate the A. Can we like refer easily in the Sphinx document? Okay, I think that's probably then sort of incremental step we can make, basically describe the PDE, discretize, and basically point to where the API is. So if we're really interested in gory details, they can take a look at the code.
It's true, yeah, because the website's going to auto-generate the API, and then it will auto-generate the hyperlinks. And then whenever we make this theory section, I think those will be created after the API is auto-generated, so you should be able to go find it.
So to kind of make progress on this, I know we're a touch over time. I'll throw out a suggestion and we can see if this makes sense. Because I think that, like, we want to figure out, I guess, where different pieces of information end up fitting. I think that's like, the content generation is of course a challenge, but right now I think the thing we're facing is sort of, where do bits and pieces of information sit? Would it be helpful to just like start with a question? Like Doug, you had a couple questions sort of thought about and Jaja as well, with respect to basically how do you go from this equation to the implementation, and then from a user perspective, how do you sort of responsibly use that implementation? What are things you need to be aware of, like boundary conditions or and such? Would it be helpful to sort of just like start with a single question and then outline kind of step by step what you would like to see to address that question? And then we can figure out where those pieces of information kind of fit. Does that sound like a concrete enough?
That sounds like a that might be a good step forward, be kind of concrete with respect to, yeah, and then we've got the DC, so we've already really focused in on something. So then it's a matter of, of kind of parsing out basically what that pull request is at this point, and formulating a couple of specific questions that are connected with that, and then see, okay, what's required to answer it and where should everything live? Can we just have links to specific papers? Do we actually have another document that is providing missing details? Just try to sort of sort that out as we're trying to get something. Yeah, I'd be happy to try to do that. Might ask for some assistance, but
that sounds good. That sounds good. And Jaja, if you have time to also even just document a single example of just like, here's some pieces of information that I feel are missing that I would like to see. Doesn't need to be anything sort of in depth, but I think having a couple of perspectives on that would be really valuable.
Yeah, sure, yeah.
Cool. Does anyone else have comments or thoughts on that approach? Does that seem reasonable?
Yeah, it's more of like, in terms of an actionable item for this, what we want to do with this theory section, I guess I'd like to put something down as like a goal for either next week's meeting or the week after, something that really ensures it's going to move in a forward direction.
So I think we're sort of in the think twice, act once phase on this. And so maybe one thing that would be helpful is if you want to sort of put down a couple thoughts on maybe a bit of a template, what you have in mind for DC, for example, and just kind of get some thoughts down on this Google Doc, and then we can sort of take that and see if it matches with Doug's questions and Jaja's questions, and if there's a trajectory through that, or if we need to kind of rethink based on the questions that are being asked.
Yeah, sounds good.
Cool. Joe, did you have any other thoughts on that?
No, I think that's good.
Okay. Cool. Anyone else have any other thoughts, last burning questions, items? No? Quiet? All right. Well, thanks everyone. We'll call it a wrap and let you go have lunch. And we'll see you all next week.
Yeah.
Thank you.
Great.
okay.
Thanks everyone.
Thanks guys. Thanks Vince.
Bye-bye.
With everyone. Take care.